Okay, okay. So today I'll be covering basics of groundwater hydrogeology. So I'll go from the slide move on here. So when it comes to distribution of water, we know that most of the water are in a saline form. 97% of the water in a saline form. Slide move to can I do? One I don't know. No pointers. Yeah, they find. Okay. So this is a distribution of fresh water on Earth. Most of the water, 97% of the water are in the saline form, oceans and all, and fresh water is the 3%. Of those 3%, 68.7 are in the polar ice caps and glaciers, and groundwater constitute 30.1%. So we can see the amount of groundwater is very meager on the surface of the Earth. So if we come to the basic, this is a water cycle. This is hydrological cycle. How does the water moves? This is it's a very schematic diagram because most of the we know that mainly what contributes evaporation, evapotranspirations, ultimately sublimations, and when it forms the clouds and condensation, and it falls back to the earth. So once it falls in the form, mainly falls in the form of rain to on the earth's surface. So once it forms the rain on earth's surface, there is means we know that we should know what is the capacity, because most of them goes in surface runoff, and about 30% is 30% we call the infiltration of the soil. So ultimately infiltration is the factor we recharge the groundwater. So in terms of source certainty, so this is a very important factor is there, because just because of the rainfall doesn't contribute to the whole 100%. So there is a surface runoff, there will be infiltration. From the infiltration, there will be base flow. So the lateral movement of groundwater is very slow. It's like around 0.01 centimeter per year. So that's why because when you extract water, because it takes time to recharge, because the source is somewhere. It's not that the source, because ultimately the recharge of the flow of groundwater, the base flow depends on the gradient also. So ultimately, you can see once the groundwater that we extract, we can see the recharge can be 10, 20, 30 kilometers away also, recharge area. So that's why this finding the recharge area and all those things are important. Now people are coming to the concept of climate change. Why the climate change is hampering us? So this is the basic base. From this schematic diagram only we can make out. So if there will be evaporation will be more, the condensation will be less, ultimately there will be misbalance, and ultimately we as a human being, we need water for survival. So extraction will be, if extraction is more and it is not being refilled properly, so ultimately there will be a scarcity. So these are components of the water cycle. These are evaporation, as you will know, there will be evaporation, transpiration will be there, then sublimation, there is interception loss, condensation, precipitation, runoff, infiltration, and percolation. So as we know, the evaporation is loss of water to the atmosphere due to vapor and pressure gradient. This is those factors affecting our temperature, sunshine, wind velocity, humidity. These are basic things: cloud coverage and barometric pressure. Transpiration, transpiration happens through the soil moisture and through the leaves. So this is how the transpiration happens. So evapotranspiration is a mixture of evaporation and transpirations. So intermediate loss in evaporation. So ultimately, after that there will be sublimation because it is solid and a gaseous matter with intermediate liquid stage. So there will be the interception loss will be there, and after that there will be condensation. Which the condensation may be in the form of rainfall, drizzle, snow, sleet, hail, as you can see on the surface of the earth. So after that comes the infiltration and percolation. So infiltration is a process of absorption of water from rainfall or other surface water bodies into the ground. So infiltration depends on the many factors also, because how is the soil quality type? Soil, if it's a clay soil, so if it's a sandy soil, so if the clay soil, I think the infiltration will be very less. So waterlogging, in some area, if you can see, waterlogging happens. Why waterlogging happens is because ultimately it doesn't percolate to the ground surface. So ultimately, if the continuous rainfall is there, we see the area of water means waterlogging. So if it is a well sorted sandy soil, the infiltration capacity is more. But you can see with time also what happens is that if there is a continuous rainfall, if it exceeds its absorption capacity, saturated, it becomes saturated, and ultimately there is a waterlogging also. So this is how the infiltration is the process. The percolation is used to denote transit of infiltrated water from the unsaturated zone. Means there are if any groundwater, if any soil surface is to be recharged, there ultimately there is a sedimentation. Sedimentation means it has sand particle will be there. So in the sand particles, there ultimately we know there are porous spaces are there, because between two particles, ultimately sand is was Si also silica medosica. Though there are porous spaces are there. So if the porous spaces has to be filled first. So once the porous spaces are filled, not filled, it is called unsaturated. Once it's filled, it is called a saturated. So it will first, percolation will transit to the infiltrated water to the unsaturated zone. So infiltration is an important component for a recharge or for anything, groundwater component. So it depends on the intensity of rainfall. One thing is there, topography is there, and the hydrogeology. Topography is the gradient is high, so infiltration will be less, because ultimately it will follow the gradient. To follow the gradient, it will cause a surface runoff. So, and intensity of rainfall is depends. What is the intensity of rainfall? So if suppose in a cloud burst is, we are hearing about the cloud burst. So there is a sudden intensity of rainfall is very high, which most of it go as a surface runoff, or the infiltration capacity is very less, because in soil takes time to absorb it. But if it's a rainfall is continuous, means in a certain amount standard, then infiltration capacity will increase. But sudden rainfall doesn't increase the amount of infiltration. So now occurrence of water, we know surface water, ocean, lakes, water, groundwater is a different is a different. So we term is a classification stream. Two streams in groundwater. Influent is a losing stream, means, and effluent is a gaining or insulated, means. Influent is a losing stream. Once losing stream means the groundwater gives to the surface water. This is the influent. Effluent is like it gains from the surface water, recharges the groundwater. In insulators, neither it recharges nor is not, because ultimately why it happens is that sometimes the groundwater table, the surface water table goes below the groundwater table. So in that case, ultimately gradient is created. So gradient cases, why the groundwater recharges. Mostly it happens in lean season. You can see like mean season. If you see these all things can be, we can make it out from the groundwater recharge contours. We used to draw flow nets and contour maps. So post monsoon, pre monsoon, you can see the water and the base level of the surface water. Then we can see a clear gradient creates. So this is how you can classify influent if it's a losing stream or it's a gaining stream. So perennial, as you know, it's a continuous flow, and ephemeral is a response to precipitation. The stream is effluent if it receives water from the groundwater, means also gaining stream. So if stream is influent if it contributes to the groundwater. Now if you come to the vertical distribution of water, you can see, so what is groundwater means all subsurface where subsurface water that fills up pores, fractures, or other space in rock strata in the unsaturated zone of geological formation. See now, when you consider the case of groundwater, here in Brahmaputra alluvium plain, we'll consider is the sedimentation, because we'll see the pore spaces, because the time again the river has brought sediments. In sediments we can see there are many coarse sediments, there are finer sediments, there are all the mix, all they get mixed, and there are pore spaces, and ultimately when there are unsaturated zones are filled by the recharge of the groundwater. But in hard rock areas, people coming from Shillong and all, you can see the gneissic terrain because this is a pre-Cambrian terrain. We can see the Shillong plateau, or in people coming from Karbi Anglong area. This is a part of the Meghalaya. There you cannot find pore spaces. There, what is there? These are the secondary fractures. Fractures in there because during the formation of earth, there are, because simply now you can see that example of an earthquake, or when there was an Indian plate collided with a Himalayan plate. Those are like a massive amount of forces has been generated. Take a simple example. If you talk about fractures, like when you take a hammer and you hammer a small hill or something, a rock, no, it breaks into 4 or 5 pieces. So as you can, there is a minor fracture, there is a minor pressure we have applied onto a rock or something through a hammer. But the compressive forces of the earth, how much gigaton forces will be applied. So when those compressive forces come, there are fractures, weak planes are there. Ultimately, what is in rocks are what? These are made up of chemical, SiO2, quartz, everything is a chemical. They have a chemical bonding. Ultimately, when there is a weak bonding, there are the fractures is there. Fractures, what happens is those are the weaker species. So ultimately, when in a hilly area, suppose in Meghalaya, the gneissic terrain on, the water will flow to the where? Because water needs storage spaces also. Ultimately, flow from a gradient, they will come as storage, and those storage spaces in a hard rock are called fractures. Those fractures are actually plane of weakness. So when you go for a well in a, suppose in a hard rock area, we need to see there are lineaments. Lineaments means they are plane of weakness. We can say, you can easily find out in a lineament. Suppose now, Kopili, most if you can see the Kopili river is a surface. Kopili river, as for people from Assam, they have seen a Kopili river. When you see in the topography, Kopili river, it clearly divides the Meghalaya plateau and the Karbi Anglong. On the other side, there's a Meghalaya, and this is because there is a big fault area. So now, presently CW is working on an earthquake sensor also along that plane. So those are planes because from the topography we can make out, because due to some forces on the earth, there was a faulting and those separated those plateaus. Likewise, you can now, if you can see the compressive forces there, no, you can see in a rock area, we can from the satellite imagery, if you can see, observe by geology, you can say there are lineaments are there. Lineaments are plane of weakness. And you can see once a rolling hills are there, one hill ended and other hill started. Suppose in Guwahati also you can see there is a plane of weakness. If you find in Sonapur, all the Sonapur area, even in Narengi area also, you can see, if you see from the satellite image, you can see there are two hills joining in. There is a means separation between two hills. Means those are the plane of weakness. I think ultimately where there is a plane of weakness, there must be some faulting structure there. So ultimately when the ground water or rainfall it falls, it will flow through a gradient. And where will the water go? Not everyone will flow through the surface and come to the surface, but some of it will enter into those fractures. It is not only for this time, because we have to see millions and millions of years water has been stored. So if you can trace a fracture, then we get a good amount of water, because this is mostly important in hilly areas. Even in Guwahati means we actually, when you go for water wells, I can give some example. Yeah, I can give latest example is in BSNL telephone exchange in Pan Bazar. We we wanted a piezometer there, so we went till 184 meter. Till 60 meter there was this soil, means we call it weathered zone, because weathered zone ultimately in hilly area there are two things. Weathered zone. Weathered zone is what valley fill, because those hills, they have been time and again there was deposition is there, weathering is there, all time they have deposition and come as soil layer, means they have formed as sedimentary layer. Not sediment, you can say it's a valley fill deposits, not like the sediments of the Brahmaputra valley, but these are valley fill deposits, because those are from the weathering and everything. So it is up to a depth of 60 meter in Guwahati, somewhere 24 meter, but in Panbazar we got it till the depth of 24 meter, 60 meter. After 60 meter we got it hard rock, but we couldn't find fracture till the depth of 185 meter. Till 185 meter we got a very good fracture. Fracture was such high, pressure was such high that we cannot go further drilling. So this type of things are there, because in hard rock area these are very challenging thing to find water, especially from those people from Meghalaya, Karbi Anglong, and even in Guwahati also, because Guwahati is a part of the Meghalaya plateau. So but if you go for the Brahmaputra valley, I mean people from PACD they'll be knowing, in Brahmaputra valley you don't have any problem. You dig a well, you get water, especially in any area. While somewhere in, if you go to Karbi Anglong, sorry, Kokrajhar, Baksa and all, you might encounter boulder. But if you go to the upper Assam side, even Sibsagar, Dibrugarh, Dhemaji, you need not worry for anything, because you dig a well, 50-40 meter will get ample amount of water, because there's already saturated, because those sediments are, there are sediments and pore spaces that has been, and it is a continuous sedimentation. You don't, because I'll come to it. There's a confined, unconfined aquifer systems are there. That is what is groundwater means. There are two types of water we have to understand. This is means one is like uh, hard rock formation is. Now if you come to the, this is for the unsaturated zone, means within the zone of aeration. Zone of aeration is the region between the earth's surface and the water table. Now actually what is water table? Means we have seen the dug wells and all. Water table is like when the pressure of water is in equilibrium with the atmospheric pressure. That is where the means ultimately it's a pressure thing, because everything is under pressure. So when equilibrium, it is in equilibrium with the pressure of water, is equilibrium with the atmospheric pressure. That is where the water table is. So ultimately, the zone of aeration is where the main component is the soil and rocks. Their pore space at time partly filled with air and water, because it is the root zone or everything, because it might be because it is in very contact with the atmosphere. So it can be filled with means water and air, and aeration occurs when the air and water mix or comes into close contact. The zone of aeration is an unsaturated zone of wetter zone or zone of suspended water, because the water is here held by the force of surface tension or the capillary forces there. So this is called a zone of aeration. Now, ultimately next comes the soil water zone. So immediately below the rain surface, the root zone, we can find up to 2-3 meters, we call it the root zone. Soil moisture is available and direct evaporation to atmosphere. Now the intermediate or the vadose zone, it is the lies bottom of the root zone to the capillary zone. Means ultimately in the capillary zone is lies above the water table up to the capillary rise of water, because ultimately rise of water depend on surface tension forces, because all those soil particles, they have a surface tension, because ultimately it's a molecular force. SiO2 is there, even water is H2O. So there is a molecular attraction, there is surface tension forces hold the water. So ultimately, so what happens is the water, like capillary rise of water is there. So water is drawn from the zone of saturation and held against the force of gravity. So this is called ultimately when the zone is saturated, we call it saturation zone. But where the equilibrium, where there is a the pressure of water is in equilibrium with the atmospheric pressure, we call it the groundwater table, or where we see in the surface extension is the groundwater table. Now come the zone of saturation. Ultimately, when we see infiltrations and it percolates and it fills the totally completes the with pore spaces fills with so water. So the zone of saturation, the ground immediately below the water table, the pores and fractions in soils are saturated with water. The width of this zone may be actually smaller, because it depends on the area to area. So this zone of saturation in Brahmaputra Valley or in something Ganga alluvial plain, if you go to there, you can find up to. When I was in Bihar, we got a zone of, we didn't got any clay layer. In near, I think people from Bihar, there is a confluence of one Kursela river and I think the Ganga river. In the confluence, so up to 280 meters, we only got it sand. But in some cases, there are intermediate clay layers because it depends. But here, as I have told, somewhere in Valleyfield area like Guwahati, just near Tetelia Bori area is near to our office near Betkusi. There this soil zone or this weathered zone is up to 24 meter. Whereas in Pan Bazar we got it, not Pan Bazar, BSNL we got it around 68 meter. So it varies because depends on the topography and area and the well. So depends on how thick will be. So ultimately the water table is the underground boundary between unsaturated and saturated zone. So it is when water table is the pore pressure equal to atmospheric pressure. So there is a so and it varies according to season. We know with pre-monsoon water table goes down. Means mostly here in Guwahati area or in Meghalaya people also will knowing the water table goes down before the onset of monsoon, April, May. And so after monsoon, because now the monsoon, if it is ample a good amount of rainfall, so it slowly recharges, and then that reflection immediately we might not see it. The reflection can be seen post monsoon, November, December. We can see the reflection. We have those, but I forgot to write it. I can clearly show you from that. We have digital water level recording stations, so you can see how it varies seasonal wise with rainfall. You can after with that we can collaborate with rainfall. So, but it depends on the aquifer type also. I'll come to it. There are two types of aquifer: confined, unconfined aquifers are there. So, how does it react? So now these are ultimately when it comes to aquifer means to be an aquifer is actually a reservoir of water, the groundwater. To be an aquifer, it has to be porous, means it has to hold able to hold water, and permeable. Permeable means it should be interconnected and water should move through, and it should have means yield sufficient quantity of economically sufficient quantity of water to a well. Then only it is an aquifer. Suppose by being porous or permeable is not a possible. Now we can see gravel and sand are example, but clay in the sense that clay is porous, it holds water, but it doesn't transmit water. So that is one, because transmission is very slow. So that's why you cannot say, but then we call it an aquiclude. That is, it's porous and but not permeable. It can hold water but cannot transmit water. That's why you call it is an aquiclude, clay or shale. Aquitard is like porous and poorly permeable. And there is sandy clay. Sandy clay is like clay and sand is mixed. So when you get a sandy clay, that means if you suppose we are going for a water well, but lithologically we get various formations. So water well means most you might be having water well at your home, right? Like you have gone for tube wells and all. PhD people will knowing, and other people as common household also we have our own this thing tube wells at home. So when you go for a drilling in CW, we get the various formations. We see the sand is there, gravel is there, coarse sand is there. They have sediments at a particular size. As if it's a sandy clay. So now if we have to give us means we have to yield water, then if we sort out the sediment, we just need to consider the gravel and the sand, because these are the most potential zone. Now suppose if we go for a sandy clay area, suppose we thought that okay, we'll give our stainer or slot here in sandy clay, that might not yield that good quantity of water. It will yield, but the quantity will be lesser. So these are the things when you go for means these are the water bearing formations actually. So aquitard, as you know, and aquifers neither transmit nor yield water. So like massive granite, the people Shillong, Meghalaya plate. If you don't find a fracture, if it's a massive rock, it doesn't have fracture, means cannot yield water. So this is an aquifers. It neither transmit nor yield water. Now there's an aquifer is, as I have told, what is an aquifer? Means it's a rock formation. Actually, it's a rock formation which can hold water. It has to hold water, means it is a porous, and transmit and yield appreciable quantity of groundwater. Transmit means it should be permeable, so that it can yield sufficient quality of water. To be an aquifer, it has to be porous and permeable. Examples are gravel and sand. As you can find in the Brahmaputra Valley or the valley fill area. So there are types of aquifer. Unconfined aquifer means unconfined means there is no confining layer, as we can say. Confining means and confined aquifer is there, semi-confined. So unconfined means when you supposedly if we have gone for a water well, so we are continuously we are going for digging. Means we are boring the hole, we are using a machine, and continuously we got sand. But there is no confining layer. Means confining layer means it should be an aquitard. Means clay. Like a clay means what a clay holds a barrier. So if there's no clay layer, no sandy clay layer, nothing is, we call it unconfined aquifer. Continuously sand, it is not in confining. But when it comes down to confined aquifer means there's a confining layer in the aquifer. Suppose if you got around 50 meter, you got sand, after the clay layer you got, and again you got a sand layer, and below 30 meter again you got a clay layer. So that is a confining aquifer, which is in a confined condition. Confinement, suppose this room, if you can take an example, practical example, if you see, it is two means the ceiling and the wall of between this, if we pour water into it in this chamber, it will be like a confined aquifer. Supposedly the wall doesn't, this building doesn't have a ceiling here, and you pour water in it will be in an unconfined condition. If you see in a practical, means if you can imagine it in imaginary situation. So this is a schematic diagram of types of aquifer. So ultimately we call it a purse water table. Sometimes artesian flow is also there when the pressure of the water is more than the atmospheric pressure. So this is sometimes you can see, you heard that auto flow wells are flowing continuously by itself without any pumping. Actually these are like artesian well when the pressure, there is tremendous pressure, because when in a confined, because the water has also its own pressure, and if it is in a confining condition, then hydrostatic pressure, lithostatic pressure is there. So when you puncture it, suppose that it's like puncturing is releasing the pressure. If the pressure is very higher than the atmosphere, so ultimately it will outflow by himself. So that is called artesian or flowing well. So now you can see here, this is in a confining layer. This is, if you can see, this is a clay layer, suppose. this gray color is a clay layer. Between two clay boundary, if we go for a well, this is a confined aquifer system. And in unconfined, you can see this is the ground surface, this is a water well. There is no confining layer. Till here, this well is an unconfined layer, and this is in a confining layer. Means it is under two confined situation. Now this is in a schematic diagram. Now what happens in the ground situation? It alters. Suppose we went for a well. Suppose now we found that this whole area is surrounded by clay, so we cannot go for a means we won't get a sufficient potential zone. And if beneath here we got some sand layers or gravel layers are there, then we have to go for a well over there. So this well will again beneath, if we find another again clay layer. So ultimately, if we have to means bore a well, then we have to go for a confining layer. So it depends, because this is a hypothetical situation, but a schematic diagram. But practically it depends on what type of what is our target area, and depends on if our well has been desaturated also. Depends on many conditions. Like I can give you one practical example. Last time, sir and I, we went for this BSNL survey, Guwahati survey area. We went till 92 meter. So this is a very good layer. Good layer in the sense gravel, sand. We thought we'll get very good potential amount of water. But what happens is that water was very meager. So what ultimately you can see, due to urbanization and all everything, everyone has tapped those aquifer. And after tapping this aquifer, it is completely desaturated. Practically, by finding those layers, we should get good amount of water. It should be a good aquifer, but ultimately because of desaturation and continuous pumping, it is desaturated. So those situations comes in, it has to be taken into consideration. Now this is if you see the unconfined aquifer is not overlain by any confining layer. It is unconfined, but has a confining layer at the bottom. Means this whole area is sands and aquifer, and beneath is there is a aquiclude zone or a clay layer. In unconfined aquifers, the upper surface is defined by the water table. That is, means water table is the physical, means what you see when the water pressure is equivalent to the atmospheric pressure. So rise and fall is correspond to the season, because monsoon there will be a natural rise of water, but in pre-monsoon it means it clearly reflects, because the recharge is clearly reflected in an unconfined rain. As soon as there is a rainfall, there will be quick recharge, but there is no rainfall in lean season. Suppose in March, from this December to March, April and all, if there is no potential, the water table will go down. The rise and fall of water correspond to change in volume of water storage. Now, confining aquifer, the confining aquifer depends, because it is overlain and underlain by a confining layer. It means it will be aquiclude or aquifuse. Means, so water occurs under atmosphere which is more than the atmospheric pressure, because it is beneath the confining layer. Because if you puncture a hole, it will be more than that. So when a well tapping this aquifer, the water level rises above the top of the aquifer, because definitely it will be. It is in a compressed, suppose it's like puncturing a balloon. In a balloon, if you just pinch a hole, it will burst out. So same thing happens. It is water is under confining stress. So if you puncture a hole, so water table will rise above the means above the confining layer. So it will rise up to an elevation. It is in balance with the atmospheric pressure. Ultimately, and those imaginary in a confined aquifer, those imaginary water table we don't tell is a water table. We call it as a potentiometric surface. But artesian flow is if the piezometric head of potential level is higher than the land surface, means it is the water will be pushed upward in a well and emerge at the land surface without pumping. And this is a free flowing well when it is under tremendous pressure. So semi-confined is the aquifers are not the liquid aquifers, means in a liquid upper and below are aquitars, or means in a sandy clay or those area we call it semi-confined. Now there is another called purse water, purse aquifer. It is a special type of unconfined aquifer only. Supposedly, see, sometimes an impermeable bed of clay or silt may be present in some areas above the regional water table. This is the suppose this is the well hole, and this is the water table, actual water table. But in earth, beneath the surface of the earth, nothing is uniformity. There will be like sometimes clay bed might come out, and above the clay bed, in a smaller area there is a sand area. So you can see there's a purse water body, because you can find water. But what happens is that it dries up in the lean season. But actually, this is a not general, it is a not regional groundwater table. But due to sometimes, because nothing is uniform in Earth's surface. So those type of aquifers are called as porous aquifer. It's a special type of unconfined aquifer. You can see that sometimes an impermeable bed of clay or silt may be present in some areas above the regional water table and within the weather zone. This impermeable bed intercepts downward movement water and causes it to accumulate in the. So as there will rainfall, it will recharge, but in the lean season, it may get dried up. Sometimes you can see in dug well also, if you can observe, the dug well dries up in the lean season, but after rain it fills up. So this may be in the porous aquifer. Those are porous aquifer. Now, aquifer is what is there. Since if it has to be aquifer, in a simple terms, it has to take water and it has to give water. In very simple terms. So storage are the porosity, specific storage coefficient, specific yield, and transmitting a hydraulic conductivity and transmissivity. These are the properties. One is the storage property, one is the transmittivity. Then only means it will be we can call it an aquifer. Now storage property, see this is a porosity. Porosity means what? There's a in any type of to be an aquifer, either sand, gravel, as I have told, there will be pore spaces. After deposition the earth surface, there will be pore spaces. So it is the means void spaces or pore spaces. Ultimately, in those pore spaces only water will be held. Means held by the forces of surface tension forces are there. So it is, if you can see the porosity, it is the ratio of the volume of voids to the total volume. Suppose if this is one dry sand layer and water has trickled down. So ultimately those pore spaces have been saturated. So in the total volume, what is the amount of pore spaces are there? So that we consider as a porosity. So well sorted means if you can see these sand sediments are well sorted. So porosities, porous spaces are good, porous spaces are there. So it has a high porosity. Now poorly sorted has a low porosity because in between the pore space you can see is other not uniform particles are there. Coarse grain, medium to coarse sediments will be there. So it will definitely block the pore spaces, and most of the time it might. So it is poorly sorted low. Well sorted sediment deposited on well sorted sediments. See now the gravelly soil we can say, if you find means mostly in Assam and Chirang, Baksa, those areas you can find the gravelly formations are there. So those areas they are well sorted. Also, if they are well sorted of uniform size and deposited pebbles couple, they are very highly porous. Means the aquifer will be very high in those areas. And sometimes well sorted sediments also because dissolution, mineralization, many things happen because ultimately since beneath the surface many things are under the hydrospheric pressure, lithospheric pressure is there. So dissolutions happen, mainly chemical reactions happen. So what happened on those porosity areas are blocked, mainly in carbonate areas and dissolutions happen in carbonate sedimentation, carbonate areas. Not here in you can read this here in this less, but in those carbonate area. Now types of porosity is that this is void spaces forming by the sedimentation is called primary porosity, and secondary porosity is there due to secondary forces, not primary forces. That fractures, these are because these are the compressive and tension forces on the earth surface. Because due to this they have formed void spaces that is called secondary porosity. Or solution cavity in limestone area. Limestone area you can find solution cavity because dissolutions, chemical reaction, there will be solution cavity, and those are called as secondary porosity. These are the types of porosity. Fracture rock, as I have told, secondary porosity, metamorphic igneous rock in those in Precambrian Assam, Shillong, Meghalaya plateau, you can find those type of thing. Here in valley fill deposits of Brahmaputra Valley or something, we can find sand, gravel, and other classic intergranular porosity. Now there are porosity range are there. So soils you can see the porosity is very high. Clay also is a very good porous, 45 to 55%. But gravel 30 to 40, sandstone 30 40. Now after porosity there are two terms are there. Specific yield. Yield means when water is drained from a saturated material by the force of gravity, only part of the total volume stored in a pores is released. Because whatever when you pump a well, means when you pump a well, ultimately what happens? It creates tensions in the pore spaces, and ultimately water has been released. So how many volume of water released is that when water is drained from a saturated material by the force of gravity. Ultimately, force of gravity, and that is called a specific yield. Now, after draining, what happens is that in the intergranular spaces, there is a surface tension forces. So water molecules are held by those surface tension pressure. Whatever is written on those intergranular spaces, it is called specific retention. Uh, uh. So now it depends on the yield type also. It depends on the grain size also. What type of grain size? If the gravel is there, the yield will be more. So now if it is a clay rich area, so the yield will be less. So depends on how much those once the pore spaces held water and how much we can expect by the force of gravity, or in simple term, if you can well pumping out a well, how much water will be extracted. So that is the called as a specific yield. So after a specific yield, whatever is retained, that is called specific retention. Now, ultimately, specific yield and specific retention is the porosity. Mainly porosity from the porous space, how much we have drained and whatever is retaining due to capillary forces or surface tension forces, that is called as porosity. Suppose a zero point 0.2 meter cube of water is drained from 1 cubic meter of saturated sand. The specific yield of sand is called 0.2 or 20%. In terms of, sir might tell you in terms of percentage, 20% sand is. So that is means in 100 means even a 100-meter cube, 20-meter cube drain out, it is a capacity of 20%. Will 20% because sand, since it is sand and sandy area, 20%. If it is a clay rich area, other area, the specific yield will come down. Sponge, same like sponge. So we can take the sponge and after once we press the sponge, the water drains out. So whatever is remaining in the sponge, that is the specific retention. In a simpler terms, in aquifer also, uh, it is cold but drained by gravity. But drained by gravity means it is infiltrated but through recharge also. But here draining the gravity in practical term, if we take a yield of a well, that is by using a pump only, because it is in a literature theoretically that is drained by gravity, but drained by gravity will, because in order to find in a surface means if we want to do it experimentally, ultimately we have to use a force. That is the natural force, but here the force will be by pumping. When we do a pumping test or we take the specific yield, that is we create a force or any effort that it gives tension is created and it drains out. Mm. So it depends on the shape and size of the particle, means how the uniformly given distribution of force, that is if it is uniformly distributed, or compaction is if it is well compacted, it will especially will be less. So specific retention increases with decreasing grain size, because retention increases. Why it increases? Because the surface area is more and it holds the surface tension forces are more. That's why the specific retention increases with the decreasing in grain size. So it is not necessarily that soil with high percentage of high specific yield, because the soil may have low permeability and water may not easily drain out. Ultimately, for example, see the clay, as I have told, clay has a very high porosity, but they permeable because spaces are not interconnected. It holds water, but there is no interconnected spaces. There is less permeable. So this is specific storage is there. This is the volume of water released. This is uh, it is for unconfined aquifer. This is the volume of water released from per unit volume of aquifer under unit decline in hydraulic head. Now, what as you can see on the surface of the earth, what is actually is the water table, means water table or hydraulic head. It is the potential energy of water at that certain point of time. Potential energy, the gravitational energy. So once it moves, it accumulates a kinetic energy. So, that is why that is the actually hydraulic head is the potential energy of water at that point, at that particular point. So that is actually hydraulic head. We call it hydraulic head. So in an unconfined aquifer, so you can see the water is released from the storage mainly due to gravity drainage and not due to compressible material. Now this is in an unconfined aquifer, but in a confined aquifer, the things are a bit different. So there is the, because water is under pressure, because it has also its molecular H2O, it's a molecule, it gives also pressure. Now the matrix, the clay matrix and aquifer, it also builds another pressure. So there are two pressure that acts on it. One is the compressibility of, means compressively aquifer compresses. Once you puncture a hole in a confined aquifer, suppose in a confining layer, here if you puncture a hole in this well, so if the water is there, the compressibility of the aquifer will compress because it has a matrix, because it is sand, clay will be, anything will be there, it will compress. And since water is under stress, once you release the pressure, it will expand. So ultimately, the storability, take it water as in a storability of a confined aquifer, it depends on the compressibility aquifer and the expansion of the water molecule contained in it. As a result of reduced pressure due to pumping, so means puncture a hole and we create a pressure due to pumping. So ultimately, there are two forces acting on it. The water molecule, it will expand, means the water, and the aquifer matrix, it will compress. So two forces are acting on it. Now, if you come to the transmitting properties of the aquifer, so now we know that since it is porous, water will hold in the interstices or the void spaces. Now, to be a water, to yield the water to a well, it has to be permeable. Means the pores has to be interconnected. So once we pump a hole, pump a well, it means the water pass through the interconnected spaces. So that is means with if it is the ease with which water move through the interconnected pore spaces, it is called permeability. Means how much well connected the interstices spaces are. So that is called a permeability. Means sometimes, as you can say, the clay, as you can see from this example, clay is porous, it is holding water, but there is no pathway, or there is voids are not interconnected. So it is not permeable. But whereas in case of the sand, gravel and all, it is porous as well as the pores are interconnected. So that is why it is porous and more permeable. So you can see we can see permeability. We can go there, as you can see. Permeability is very less for the clay, 10 to the minus 8 to 10 meter per day, and for the coarse sand, 20 to 100 meter per day. So permeability, coefficient of permeability K. Hydraulic, we call it the hydraulic conductivity. How easily it can conduct. I mean, the ease of flow or permeability is called it is defined as a hydraulic conductivity. It is measured by the rate of flow for the unit hydraulic gradient. Now suppose when we know that water means hydraulic head is the potential energy. Now, if you are pumping a well or something, ultimately it has to follow a gradient, and because it is by act of gravity, it will follow a gradient definitely. So after potential energy, it will turn into kinetic energy will take place. So hydraulic, there will be gradient difference between the 2 points. So it is measure a rate of flow under unit hydraulic gradient, means at the through unit cross section area under area is called coefficient of permeability, and it is called hydraulic conductivity, and it is expressed in meter per day. Now transmissivity is what I said. It is a measure by the rate of flow water unit hydraulic gradient. So ultimately through a vertical strip of aquifer unit width. So suppose vertical strip in a unit width of aquifer, so we will consider the ease of flow of water or the hydraulic conductivity through a unit saturated thickness, we call it a transmissivity, because it is measured by the rate of flow water under unit hydraulic gradient through a vertical strip of aquifer of unit width extending the entire thickness of the saturated aquifer. It is hydraulic T equal to Kb means hydraulic conductivity multiplied by the thickness of the saturated thickness of the aquifer. It is called as transmissivity. Now you can see there is a thing called cone of depression also there. This is the hydraulic gradient. Now the more saturated the aquifer will be, the cone of depression will be less deeper, because ultimately once this is highly saturated, well connected, porous, permeable. Once you pump out, the pore space, void spaces are easily filled. So the cone of depression will be less deeper. Now if it is porosity, permeability is lesser, then you can see the cone of depression is more. the void spaces are not being easily recharged. So we can see from the transmissivity drawdown, we can compare how saturated the aquifer is, because you can see the down of depression is less deeper in terms of a very well saturated aquifer. This is transmissivity, high transmissivity, cone of depression low, the cone of depression deep. Now, groundwater flow, it follows a law called Darcy's law. Means we got a rate of discharge or volume of water flowing in a unit time. We consider meter cube per day through a aquifer media. That is proportional to hydraulic gradient, because the flow is proportional to hydraulic gradient, change in a hydraulic gradient, and the cross-sectional area, and inversely proportional to the flow path. That is means here that Q is proportional to A is divided by L, means K is, now there is a constant called K, and K is the hydraulic conductivity. H is the differential altitude, and L is the horizontal distance between 2 points. That is for a, but in 3-dimensional, this is for a point source, linear 1-dimensional. This is one. But the Darcy's law in 3 dimensions, we have to go for a differential, because ultimately the vector force and the 3 vector force area to come into place, because this is for a point source in a linear dimension. Now this Darcy's specific discharge refer to groundwater flux or discharge per unit area, or Darcy's discharge is equal to. Now, for considering all these things, transmissivity, permeability and all, because we cannot just go for a, we cannot say that, because we need a scientific, some experimental thing. So that's why we go for aquifer pumping test, or it's a well loss step drawdown test, because ultimately when we pump a well, or when this thing forces have been generated, then there will be drawdown. So once there is a drawdown, there are loss, aquifer losses are there, and this is called as drawdown from linear well loss. Well loss is there, and drawdown from non-linear loss due to pumping, and we have to consider both in the consideration. And after that only we can go for a this thing, we can ascertain if the storativity, transmissivity, conductivity. When means when that cone of depression we are talking about, this ultimately cone of depression is the hydraulic gradient. Between once you pump a well, because water will be extracted for discharge will be there, so definitely hydraulic gradient will be created. So from those hydraulic thing, we can take out the transmissivity, storativity, and permeability of an aquifer. These are some of the thing we do at the field, step drawdown test, because PhD, I think people from PhD level knowing to efficient or how well efficient the well is. We have to go for a step drawdown test. Means we have to increase the discharge. Means, I mean, to the maximum discharge, how much the well can, capacity of the well can yield. So that is we go for transmission. From there we can do the well efficiency test. We do some specific drawdown and discharge. We take it out, and after that we go for a aquifer pumping test, the long duration test in 1,000 minutes. Mostly here we go for the 1,000 minutes. In a median discharge, average discharge, will take an average, will pump the well for like 1,000 minutes. How much after that, what is the recovery? Ultimately is not only pumping, it depends on the recovery also, how well the well can recoup. Depends on the aquifer property. If it is very well saturated, indoors and barometer, it will take around half an hour, but if in a hard rock area, it will take around 5-6 hours to recover. So that also depends, because when you go for the how many maximum hour of pumping you need to define, that depends on the recovery also. Without recovering, if you go for a pumping of a well, the water has fully recovered, and definitely there a breakdown of the motor will be there. People will say we haven't got water and all. So ultimately, only pumping is not only effective. We have to go for the recovery also. We have to take into consideration recovery. These are the things, means ultimately transmissive conductivity or transmit we talk about, but ultimately in field experimentations we have to go for the pumping test. Then only just by saying also we cannot. We can give a rough estimate of it by seeing the aquifer potential, but to give an actual picture of it, because sustainability of the well depends on this factor. After we have to take out this factor also. How will the sustain? What will be the capacity of the motor is there? So these things depends. Ultimately, we'll get it out from the aquifer pumping test only. So these are the basic things. Means basic introduction I had to give you. Any questions on the? Yeah. Mm-hmm. No, 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 not it expands, not compression in the sense because it is under the pressure of confining pressure. That compression because it's under another state of stress. So once you remove puncture hole, the pressure comes down and it compresses. So that is not only that temperature compression is the different thing. This is under the because since it's under the lithostatic pressure from the confining aquifer matrix. So those from the two confining boundaries, it's like a balloon, putting water in a balloon. Once you puncture the water comes on. So ultimately why the water comes on? It expands, no? And the pressure goes down and water molecule gets to expand and water bursts out. So that concept I was trying to give. Where? Which area? Yes, we had done lots of well. PhD in CWA. We had done lots of wells. Which depends on area, which area you do. Okay, now we have done in a campus here in Bongaigaon, we have done one in Manikpur till 19 meter. I think a place called Nuagaon. We have a well there. It's a very high welding, around 8 or 10 LPS. And other areas in Baksai, we have done in Assam, lots of area we have done CW as well. Any other questions? बोलो सर एक्विफर एक्चुअली एक्विफर क्या होता है ओवरबर्डन नहीं है ओवरबर्डन इज क्रिएटिंग द प्रेशर मान that is because of the pressure because it is under constant pressure. Suppose I have given you the example of this puncturing a balloon. Overburden is what ultimately this is suppose a stack of the material earth material or belly field deposit anything is there. So aquifer is what? Aquifer is where it is porous, permeable, and it has to hold water. So ultimately, when you drill a hole, we have to cross the overburden. After that, only once you touch the water surface, suppose the aquifer surface, it will rise above the means it will come above its own aquifer area because that is due to the overburden pressure. Because aquifer is not suppose this is one of the suppose you take the example of this hole, it is filled with water. Now, if I compress it from below and from the top, and if I drill a puncture hole, definitely the water molecules, whatever what is it will expand, right? So depends on how much pressure is underneath and above it. It will come out to the surface. That is the surface extension, of the aquifer. Sir is talking about. Yeah. No, water will come from the aquifer only. हाँ. Good draw for drawdown. Yes, sir. Uh, recovery. 20-30 minutes we have got. Within 15 minutes also we have gone. After pumping 1000 minutes. No, fracture depends on the hard rock area. We have done here in Tetlebori, I have told you. Here, this well, recently we have gone in near this Hojai, Udali. There we took us around 3 hours. So drawdown was around static water level was around 22 meter, and after pumping for 1000 minutes, water level went down till 39 meter. So from 39 to 22 meter, 22 meter, it took us around 3 hours. So depends on how many hours you have pumped and what is the capacity of pump. And that depends also. That also depends. We have pumped around for 1000 minutes. So after that, it took us 3 hours for recovery. So that things has to be also considered. Here in similar in Tetlebori we have done in hard rock area. So it was drawdown of around 12 meters. So 12 meter was static and 12 meters one thing. And it took us around same 2.5 hours. But Mongoldo we did in Mongoldo high secondary. That was if the drawdown is less. Suppose when the aquifer etc. You see, so the cone of depression as I've shown. If the drawdown is less, this thing recovery time also very less. So if the cone of depression is very steep, then the recovery also will take time. Depends. That also suggests that the transmissivity. If the cone of depression is steeper, then the transmissivity is very less. Transmissivity is lower, then the well that has a very lesser cone of depression. So ultimately, it depends. The recovery also will take time. Not only finer gains, another there is a problem. If the finer gain, because of the surface tension, it will because of surface tension forces, it will hold the water molecule. The retention is more. But that is a well means it has to be a coarse, medium to coarse grain sediment, and if it is uniformly distributed, then you will get a very good means the aquifer properties will be transmissibility very high. So once the transmissibility is high, vice versa, the recovery time will be lesser. ये हाँ इसमें जैसे इसमें हम लोग ने लिया पहले ड्रॉ डाउन किया उसको ड्रॉ डाउन किया मतलब ये उसी वेल का ही है हाँ मोए गाँव का वेल का ही है देखिए आफ्टर सर्टेन पॉइंट ऑफ टाइम after 10 minutes only you can see this is a very flat curve because means the drawdown was very less, so you can see the transmission is very high. So you can from here also you can make it out. So if here the recovery time is very less because it's very steeper. If the recovery time is more, you can see a more steeper graph like this. But so from this graph also we can make it out. What is and you can see the transmissibility is 1987 meters square per day. कम आएगा इसमें बिकॉज बक्सा में है, सरायमारी में। हाँ, बक्सा बक्सा में है, सरायमारी एक है। हाँ, हाँ निम उदालगुड़ी में। हाँ उदालगुड़ी और बक्सा में हम लोग का 2 वेल हुआ था, उसमें है वाटर फ्लो है। हाँ, ये सरायमारी में है, मोरीगांव में नहीं सर, उदालगुड़ी। ठीक है। पानी पी लेना। हाँ, और আপনি দিলাম नहीं सर, हाइड्रोजन दे दियो, हाइड्रोजन আপনি দিলাম। अब थ्योरी थ्योरी है ना।